Now let's look at the unit circle and the four quadrants of the unit circle. So a unit circle is a circle of a radius 1, so you can see here that from the origin to a point on the circle, which we call xy, the distance here, the hypotenuse or the radius, is 1. Because your point is x across y up, your horizontal distance is x and your vertical distance is y. So remember, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So what this means on a unit circle is if sine of theta, the angle here, is opposite over hypotenuse, opposite is y, hypotenuse is 1, so sine is y over 1, which is y. Cosine is adjacent, which is x over hypotenuse, which is 1, so cosine of theta is x on the unit circle, and tangent opposite over adjacent, so that's y over x. So remember that tan theta is the same as sine theta over cos of theta. We've got that relationship there. Over the page, so if we look at the unit circle, in particular this point here, xy, and the triangle it forms, using Pythagoras, we have x squared plus y squared equals 1 squared, which is 1. So in other words, we get the Pythagorean identity by substituting x was cos squared, so cos squared theta plus y, which is sine, so sine squared theta must be 1 squared, which is 1. So that was the Pythagorean identity. Next table we have to fill in are the sine, cos, and tan of the special angles. Namely, in particular, we start counting our degree from here, 0. This is 90 degrees or pi on 2. Half a circle is pi, and then we have 3 pi on 2, and then back up here 2 pi in one circle. So we go anti-clockwise. So remember from the previous page, y is sine, x is cos, and tan is y over x. If we consider for these special points, these special angles, the xy coordinates, so this point here is 1 across 0 up, this point here is 0 across 1 up, because it's a unit circle, so all the radius is 1. This one here is -1 across 0 up, and down here 0 across and -1 up. So what this tells us, it's filled in degrees. 0 degrees is 0 radians, 90 degrees is pi on 2 radians, 180 degrees is half a circle, pi radians, 3 pi on 2, and we have 2 pi for 1 full circle. So if sine is the y coordinate, then at 0 degrees, our y coordinate is 0, because it's 0 up. The cosine is the x, so cosine is a horizontal point at 0 degrees. Our x value is at 1, so cos of 0 is 1, and tan is sine over cosine, so we have 0 divided by 1, which is 0. Let's look at 90 degrees. So 90 degrees, the point is 0 across 1 up. So sine would be 1 because it's 1 up. Cosine would be 0. 1 divided by 0 is not possible, so tan of 90 degrees is undefined. Similarly, filling in the points, we have 0 up, -1 across. 0 divided by -1 is 0. 270 degrees, -1, 0, and undefined. Back at 2 pi, or back at the 0 point, we have 0, 1, and 0. So the next part is just a fancy way of saying, hey, remember our 4 quadrants and the CAST. So all this colorful blurb is all about, remember, you have 4 quadrants, Q1, Q2, Q3, Q4, and remember we had CAST. So any cosine, sine, or tan is all positive in the A quadrant. Only sine is positive in the S quadrant or Q2. Cosine and tan are negative. Down in the tan quadrant, only tan's positive. And then cosine, only cosine's positive. Tan and sine are both negative. So putting that in application for example 3, we need to work out the exact values. So we've got the exact, we want to work out the cosine of 5 pi on 3. So if you're not comfortable with working with radians, that's okay. We do a little sine calc, change 5 pi on 3 into degrees. So 5 pi on 3 times 180 degrees on pi gives us 300 degrees. So to work out these exact values, draw your tiny little CAST diagram. So CAST, 5 pi on 3 is 300 degrees. So draw in where 300 degrees would be in your CAST diagram. We start counting angles. So throwback to, we start counting angles at the positive x-axis. Going anti-clockwise is positive, going clockwise is a negative angles. So over here we've got 300 degrees, so starting from the positive x-axis, going 300 degrees, it's in quadrant 4. So that's 300 degrees there. We need to work out the little angle from the horizontal x-axis. So if that's 300, that little angle there would be 60 degrees. So what this means is cos of 5 pi on 3 is the same as cos of 300 degrees, only because I like to work in degrees. If you like to work in radians, go ahead. Now, we saw that 300 degrees is the same as the tiny angle from the x-axis of 60 degrees. So we can rewrite that as cos of 60 degrees. Now, because we're in the C quadrant, we have positive cos of 60 because cosine's positive over there. So cos of 60 degrees using exact values, that's 1 over 2. So it's just positive 1/2. So let's do a similar thing, sine of 7 pi on 6. Again, if you can't visualize where 7 pi on 6 is, do a little sine calc to convert radians into degrees. So times 180 over pi, that gets us 210 degrees. So draw your little CAST diagram on the side so you can visualize where it is. So 210 degrees, that would be more than 180 but less than 270, so in quadrant 3. So from the positive x-axis to, from the positive x-axis to that angle there, that's 210 degrees. We need to work out the small angle from the x-axis horizontal. So this small angle here would be 210 minus 180, because half a circle is 180 degrees, which gives us 30 degrees. So what we can say is sine of 7 pi on 6 is the same as sine of 210 degrees, which is the same as sine of a little angle 30 degrees. But take note, we're in the T quadrant, so that means sine is going to be negative because it's not tan. So it's going to be negative. Sine of 30 degrees in exact values is 1/2. So sine of 7 pi on 6 is negative 1/2. Alright, let's then work out tan of negative 30 degrees. It's in degrees, I don't have to do any conversions, that's good. On the side, draw my little CAST diagram, CAST. I'm going negative 30 degrees, so I'm going down 30 degrees from the positive x-axis. So this would be 30 degrees. And that's my tiny angle already because it's from the x-axis, and that's all I care about. So tan of negative 30 degrees is the same as tan of 30 degrees because 30 is my tiny angle. Now look at the quadrant. We're in the C quadrant, which means tan is negative. So that tells us it's negative. Tan of 30 is 1 on root 3. Or if you want to rationalize, the denominator is negative root 3 on 3.